Hey guys, how's everything going? Welcome to Aiding Tuition AI. So today we'll be solving a problem on the Leetcode, and the problem name is two sum. This is considered as a beginner level problem. Not a beginner level, but I would say like it's a good stepping stone for starting the journey on the Leetcode. And so it has some very good concepts which we will discuss. So let's get into it. So here's the problem. The problem is that given an array of integer nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. And you can return the answer in any order. So basically, what they are trying to say is that you are given array, which is array of numbers, which in this case is like something like this: 2, 7, 11, 15, and they are giving a target which is 9, and what they want you to return is that any two numbers which have their sum equals to 9, they want the indices of those numbers. So in this case, those two numbers are 2 and 7. So because they sum up to 9, and their indices are 0 and 1. So this is what they want us to do in this question. And similarly, they have done in different questions also. Like here you can see it is 3, 2, 4 and target is 6. So 4 and 2 is the target. And here 3, 3 target would be 6. Now it's important to note that they have given that every input will have exactly one solution. So we don't have to worry about the duplicacy of those elements because only one solution can exist in the entire array. And we do not have to use the same element twice. So that means that we only have to use one element one time. And apart from that, they have also given the constraint that only one valid answer exists. So that is how things will be, that it just one valid answer will be there. And then they are saying that the follow-up is that can you come up with an algorithm that is less than the order of n square time complexity. So that means first we have to come up with a solution which is which has a time complexity of order of n square, and then we can improvise that solution to make it into something which is less than order of n square. So I think a good approach to this problem can be a brute force approach. So we'll start with a brute force approach. And for brute force approach, what we can do is that we can run across the entire loop and then rerun or like check with every element, like check 2 with 7, then check 2 with 11, then check 2 with 15, then check 7 with 11, 7 with 15, then 11 with 15. So basically you need to have two nested loops, and wherever you get the summation, that is the point where you have to return it. So in this you can simply have like something like a small for loop, which can be like for j comma I, and your enumerate is basically you want to keep a track of the index of that element in nums, right? And then second your loop can be for k in range. It will start from j plus 1 because we want the second loop to start from 7 if we are on 2, and then go on to 11 and 15. So this would be, and we'll go till the length of the nums, right? And then here we can simply check, well, if the summation, like if the two values, like if you basically I plus k equals to target, if that is the case, you can simply return the indices, which is the j and k. And if that is like if that is not the case, then you can simply pass, or you don't really want to write anything. So in this, if you will see, this outer loop takes the time complexity of order of n, because the n at worst case maximum n elements can be there. The internal loop takes the time complexity of n because at max n loops can be there. So combined, they will have the time complexity of order of n square. And we are not using any data structure which is other than the variables. So because of that, the time complexity will be straightforward order of 1. So this is the time complexity, the space complexity will be order of 1, and the time complexity will be order of n squares. And this is the brute force approach. Now, if we want to do something better than the brute force approach, then the second approach can be using your hash maps, because so in the hash maps, what we can really do is that as we see, let's write it down again. Our nums is basically 2, 7, 11, 15, and our target is 9. Now what we can do is that when we iterate through the entire loop, like when we are iterating, right? When we are at 2, we can calculate the difference. Like what is the difference? Here target is 9, so 9 minus 2 is 7. And we can use a hash map. A hash map will keep a track of all the elements along with their indexes. So we can see if this 7 is in the hash map or not. So right now this 7 is not in the hash map. So we can just proceed further because the element is not there now. And we proceed further and we add the element. Like here we will add 2 along with this with its index value, which is 0 in this case. Now when we come to 7, now when we are at 7 here for 7, for 2, for 7, here we can see for 7, 9 minus 7, the difference will be 2. Now it will check whether the difference is in the hash map or not. Now here we can see that the 2 is already in the hash map, so we will simply return the index value of 2, which is 0, along with the index value of 7, which is 1. And this will be our answer. Now here what we are doing is we are simply iterating through this loop one time, and at max there can be n elements. So this will have a time complexity of order of n. When we look up into the hash map, the time complexity is order of 1. Adding any element into the hash map is again time complexity. When we add any element, the time complexity in hash map is order of 1. And when we look at the elements in the hash map, its time complexity is order of 1. And usually in case of hashing collisions, the time complexity changes, but as a rule in general, we just follow it order of 1. So the net time complexity of this entire code will be order of 1, and the space complexity will be order of n because we are using a hash. So this is what the whole code was all about, the logics. Now let's get back to coding. So let's start with the approach 1, which is the brute force approach. Brute force approach. So in this, what we can do is simply for j, go for I, comma j, enumerate nums in range. It starts from this one. J plus nums k equals to target. Then you can simply return I comma k, else you don't have to do anything. It will just pass. And this is the solution which is accepting. Now let's try to submit it and see. Yeah, so we can see that here it has got submitted, and the runtime that it has taken is 3300 milliseconds, as you can see. Now what we'll do is we'll try to create, and so here let's summarize the approach. So here in summary, the time complexity is order of n square, and the space complexity is order of 1. Now let's just comment it out, or we can just simply remove it. Better to comment it out. It's a good rule of thumb if you are to put a null check, usually cross program, because it's helpful. So we'll just put it in the approach 2. You can also put it in the approach 1, although it does not matter because as you can see that there are no test cases which are giving you null as the input. Now approach 2 is using the hash map. So here what we can do is simply first put a null check. So if not nums, simply return nothing. Otherwise we will create a hash map. which is this. Now for I, chain, enumerate nouns. Calculate the difference, which is target minus your j. Now let's check if the difference is, if difference in scene, then you can simply return the values, which is your I here and then scene def. Otherwise, what you can do is you can simply add the element along with its index into the hash map. And this should be good enough for this case. And the it's accepting the solution. So now just, and this one is faster than 84.28% of Python online solutions, and it is just taking 44 millisecond runtime. And you can see that the memory is 14.2 MB because we created a hash map, and previously the time complexity, the runtime was 3300 millisecond, which shows that the time complexity was order of n square. So let's summarize it. Its time complexity is order of n, and the space complexity is simply order of n, sorry, again. So this is the second approach, which was using the hash map. This one was the first approach, which was the brute force approach, using in which we use two loops. So that was it for this question, and I hope you guys do. If you guys have any questions or comments or concerns, just comment it down in the comment section, and I'll try to reply back. And till then, stay safe, stay happy. Bye.